So what we are trying to do here when we run models is that we are trying to fit, for a given data, we are trying to fit a model so that we can use the model to predict future values. Okay? So we want this model that we are fitting to be as close to the existing data as possible. Right? So here is an example. Okay. Just an example from your textbook. So this is the data that we have. Okay? You can run a simple linear regression, which means it will be a line going like this, right? But the points are not exactly on the line. So the fit is not perfect. Then there is some error there, here and there, right? So each point is a little bit away from the line. So to that extent, there is some error in the model. And of course, when we are trying to fit the model, we are going to try to minimize the error as much as possible. In a simple linear regression, there is no way that you can reduce the error to 0, because it has to be a straight line. That means if you try to fit through 2 points, the other points will be off the line. Okay? If you try to fit through any 2 points, the other points are going to be off the line, so there will always be some error. But suppose you manipulate the model instead of simple regression, you put some squared values, you put some logarithms, you make the model really complicated. Okay? And by chance, you're able to hit an equation that goes through each of the lines perfectly. Okay? Now, of course, if all you're interested in is fitting a line through the existing points, then this is a superior model than to the straight line model. The straight line model is always leaving some error, whereas there is no error at all here. But that's not what we are interested in. We are interested in future predictions. Okay? So a perfectly fit model may be completely useless when it comes to the actual reason why we are modeling. The reason why we are modeling is for future predictions. And this is going to be completely useless even though it is perfect when it comes to the existing data. So that is what is called overfitting. Now, of course, here, when does, a normal, when does too much error end and overfitting begin? Okay, so that's subjective. The thing that we need to understand here is that just because in the data set, in the data set with which we are developing a model, that there is a model that gives you the least possible error, that does not necessarily mean that that is a better model. The better model is one that can predict future data, not the current data. So how do we then decide which model will do a better job in the future? Well, instead of trying to fit the model and evaluate how good it is with the same data set, okay, if you use the same data set for both fitting the model as well as evaluating how good the model is, then we will end up saying that this is better than the other one. But what if we take the data and split it into 2 and use one part to fit and then use the other one, okay, to evaluate the fit that we have come up with? So the one that fits perfectly here, then you take that and put it in here and you get, lousy results. Then you know that even though it fits this model, the model that fits very well in the first data set is really not a good model. So you have 2-3 different models that you fit here. You take those models and apply it to this data set that is virgin data set. Okay, you have not used it for model development. Then you see which one works better in this data set, which model. So that's how you will see, or you will, you can avoid overfitting. Okay? And that brings us to data partition.